Welcome friends. In this video we are going to summarize the extraction of iron, and we are going to do that by focusing on questions that comes on the extraction of iron. So here we have this question from section C where we are told iron is extracted from its ore in a blast furnace. Now first let's begin by first looking at what is meant by a ore. So an ore is just a substance that consists of a useful, so say useful substance. The useful substance is the particular metal that you are looking for. Then plus the unwanted substances which we consider to be as the impurities. So that is what we can define, or what we can simplify by what an ore is. Now each element, or maybe we can say each metal has its own ore. Like if we look for iron has two most common ores. The first one we have the magnetite. Now magnetite is rare. It has the chemical formula with 3 here, then 4 here. Then the other one is the hematite. So hematite has the chemical formula of 2 here, then a 3 here. Now why is hematite commonly used for the ore during the extraction of iron? Because it has the less impurities. So this is the reason that you need to give whenever you are told why the hematite is preferred to magnetite. So under the magnetite, the iron content is very small, so there is too much of impurities in magnetite compared to the hematite. So that's the reason why it is used mostly. Then apart from knowing the chemical formula, then let's focus on first what is what do they look for if they are looking for the method that can be used to extract a certain metal. So whenever they are looking at the extraction of metals, what they have to look at is the reactivity series, or the reactivity of that particular metal. So the most reactive metals extracted using electrolysis. So that is what you need to look at here. Then and also remember that some metals are just found in just nature. So there are some metals that are found in their native or nature form. Then others have to be extracted, and we are saying for the most reactive one have to undergo electrolysis. So these are the most reactive metals. Then for the least reactive is by reduction. Now for us to use reduction, we need to have a reducing agent, and the common reducing agent that is used during the extraction of these less reactive metals, we have the carbon monoxide and the carbon and the carbon monoxide. So these are the two most reducing agents that can be used. Now away from these basics, let's go back to our extraction of iron. So the extraction of iron occurs in a furnace known as a blast furnace. So that is what we have here. So this structure here is the blast furnace. Now away from that, there are raw materials that we need to have whenever we are dealing with the extraction of iron. So now what are these raw materials? So the first raw material that we need the ore, which is we have the hematite. So the hematite is the common name. Then the if you are told to give the chemical name for hematite, this one is iron 3 oxide. So whenever you are given this number here, it means the iron that we are using has a valency of 3. Then the second raw material that we are supposed to have during the extraction of iron, we are supposed to have coke. Then coke has the chemical name of carbon. So you need to look at the common name plus the chemical name. Then what else are we supposed to have? We need to have limestone. So limestone has the chemical name of calcium carbonate. So these are the 3 raw materials that we are supposed to have. Now these 3 raw materials are fed here, and they are collectively known as a charge. So if maybe the question comes like give a charge in terms of or maybe if you are looking at the extraction of iron, it's indirectly asking you to give the 3 raw materials that forms the charge, of which we are saying is hematite, coke, limestone. Then if you want to use their chemical name, the chemical name for hematite is iron 3 oxide. Then for coke we have carbon, for limestone we have calcium carbonate. Now each raw material has its specific role to play. Now first let's look at the 5 equations that occurs during the extraction of iron that you are supposed to have. So the first one, first we'll look at the formation of the reducing agent. So the reducing agent during the extraction of iron is carbon monoxide. So how do we make carbon monoxide? So first we need to look at the first equation. So the first equation is the reaction between carbon plus the excess oxygen. And the product here is the carbon dioxide. So this is our first equation that we'll focus on here. Then let's convert this into chemical symbols. So the first one, carbon, which is in solid state. Then oxygen. Remember, oxygen is a diatomic gas with a 2 here. Then carbon dioxide has this chemical formula. Now for the first equation, so the first equation we can see that it's a balanced equation. So and if maybe you are told to write the first equation during the extraction of iron, it's the reaction between carbon and oxygen which gives us a carbon dioxide. And the importance of this hot air, so this hot air, it just means that it's the oxygen that will react with the carbon, which is the coke. So as we insert the charge that has carbon in it, the carbon will react with the oxygen to give us carbon dioxide. Now away from there, let's look at our second equation. So the second equation, before we look at the second equation, what is the importance of the first stage? The first stage is giving us carbon dioxide. So now this carbon dioxide must be reacted with more coke to produce carbon monoxide. So let's now look at this one. So we'll say carbon plus carbon dioxide so is equal to carbon monoxide. So the importance of stage 2, or the reaction for stage 2, is we just want to produce the carbon monoxide. And what is this carbon monoxide? Remember, carbon monoxide is the reducing agent during the extraction of iron. So this is just the reducing agent. So we'll see what it reduces. So say carbon, which is solid plus carbon dioxide, CO2, a gas. Then we are saying we are going to have carbon monoxide. So the difference in terms of the chemical formula for carbon dioxide and carbon monoxide is that carbon dioxide has 2 atoms of oxygen in one molecule, while carbon monoxide has only 1 atom of oxygen. Now let's have it balanced. So we can see that there are 2 atoms of carbon on the reactant sides and 2 atoms of oxygen. So we just have to put a 2 here. So we can now summarize by saying that the importance of stage 2 is to produce the carbon monoxide, which is a reducing agent. Now, after we are done with stage 2, let's go to stage 3. Now, stage 3 is the most important reaction or stage because it summarizes the extraction of iron. So what is this stage? So let's look at this stage. So this stage is we have this iron 3 oxide. This iron 3 oxide is now reacting with the carbon monoxide. So the carbon monoxide will reduce the iron 3 oxide to iron. So to reduce it means it is going to take the oxide which is here. So it has to remove that. So after it is reduced, we are going to form the iron. So here we have the iron plus the carbon monoxide. Now let's show this by equation. So the equation is, remember, iron has the chemical symbol of Fe with the valence of 3. We are using 3 since we can see that it's iron 3 oxide. Then the oxygen has a valence of 2. So if we swap these numbers, we can see that we are going to get this formula here. So this is the chemical formula for iron 3 oxide plus the carbon monoxide, which is a gas. Then we are saying we are going to have iron, which is a metal, plus the carbon dioxide. So this should be dioxide. So the carbon dioxide. So the carbon dioxide is these waste gases that escapes the blast furnace. So remember, the oxygen is the one that enters, and this oxygen is reacting with this carbon to give us the carbon dioxide. Okay, so now let's have it balance here. So what do you think are we supposed to do to balance our third equation? So we can see that we have 2 atoms of iron on the left side, so we just have to put 2 in front of iron. So we have our iron balance. Then we need to balance first before we look at oxygen. Let's put let's put 3 here so that we have 3 atoms of carbon, and also here so that we have 3 atoms of carbon. Then from the carbon monoxide there are 3 atoms of oxygen plus these 3, so we have 6 in total. So if we multiply 3 times 2, we have also 6. So we have our equation balance. So now this third equation is the equation that summarizes the extraction of iron, and in most of the questions that I've seen, this is the equations that you are asked, and the language that you may might help you to understand that the equation that you are looking for is, you may be asked a question like write the chemical equation in which the iron 3 oxide now is reduced. So what is meant by reduced? So we can see that on the left side here, iron has oxygen in it. but after the reaction we can see that the ion is just on its own. So since it has lost the atom, or maybe the atoms of oxygen, then that element has been reduced. So that's what it means by reduction in this equation. Remember, reduction oxidation occurs simultaneously. So the carbon monoxide has been oxidized to carbon dioxide, while iron fuel oxide has been reduced to iron. Then let's move on to stage 4. So stage 4 is where we look at the decomposition of calcium carbonate. So here we have calcium carbonate. So calcium carbonate is heated. So we are going to use the double arrow. So after this is heated, it is going to give us calcium oxide, then plus, let me just write the chemical formula, plus the carbon dioxide. So even on stage 4, carbon dioxide will be produced. So this is the thermal decomposition. So the importance of carbon, we just wanted to use carbon to produce the carbon monoxide, which is the reducing agent. Now the importance of calcium carbonate, which is the limestone, now this one will react with the slag. So this will just react with the silicon dioxide to give us calcium silicate. Now let's first convert our calcium carbonate equation into chemical formula. So the chemical formula for calcium carbonate is this one, CaCO3. Then it decomposes, we get CaO solid plus CO2. And remember, this equation is a balanced chemical equation, and also you may find this equation during the formation of lime on the kiln. So this is our fourth equation, or our fourth stage. Then let's have question, stage 5, which is the last one. So stage 5, let me see if I have enough space here. Okay, so stage 5 will say calcium oxide. So from stage 4, we just want calcium oxide plus silicon dioxide. So silicon dioxide is just the sand. In science we call it silicon dioxide. And this is one of the impurities that we want to get rid of here. So silicon dioxide, and we are going to have now calcium silicate. So in chemical formula, we are going to say we have calcium oxide solid plus silicon dioxide is this one. Okay, so silicon dioxide is this one, solid. Then calcium silicate is this one. So these two atoms of oxygen will be added with this, so we have a 3 here. And remember, this equation is also a balanced equation. Now if we go back here, so these are the 5 equations that you are supposed to have as long as you are dealing with the extraction of iron. So remember, extraction of iron occurs in a blast furnace. Then the raw materials are limestone, coke, and hematite. Then the chemical name for limestone is calcium carbonate. For hematite is iron fuel oxide. Then for carbon, for coke is carbon. From there, the first stage is the reaction between carbon plus oxygen, giving us carbon dioxide. The second one is carbon plus carbon dioxide, giving us the carbon monoxide. The importance of stage 2 is to produce the carbon monoxide, which is used as a reducing agent. Then the third stage summarizes the extraction of iron, where we are getting iron plus carbon dioxide. Then carbon dioxide is treated as the waste gas, and this is the gas that we have here. Now, if you look at this here, we can see the molten slag. This is the impurity, or maybe we can see the impurities, and one of the impurities is this calcium silicate. So this is, we can see that the molten slag is on top of the molten iron. So we have our iron. This is our iron, which is the one that we are getting on stage 3. Then after this, the iron that is produced is known as a pig iron. Why is it called a pig iron? It's not yet pure. So there is a certain percentage of impurity. Now with this information, let's see if we can now answer the questions. So coke and materials X and Y are fed into the furnace. So question A, name the materials X. So X can be hematite, because we said we need to have hematite. Then Y can be limestone or calcium carbonate. Then what is the use of the waste gases? Remember, the waste gas is the carbon dioxide. So the carbon dioxide that is coming is very hot, and we can see that we need the hot air that should enter the blast furnace to react with carbon to give us the carbon monoxide. So the importance of the waste gases, which is carbon dioxide, it heats up the surrounding. So we want the surrounding to be heated up so that the oxygen gas that is entering the furnace must be heated. So that is it. So say to heat up the surroundings, the surrounding of the blast furnace, or to heat up the air, which is to heat up the oxygen that is surrounding, or that is about to enter the blast furnace. Then let's move on to question C1. What is the reducing agent in this extraction? Remember, we said it's carbon monoxide. Then describe how the reducing agent is produced. So I said the reducing agent is produced by the first 2 stages. So in your description, you can just have to give the first 2 reactions. So you can, maybe let me see if I can summarize that. So the first one, by reacting carbon with oxygen to produce carbon dioxide. Then the second one, you react now more carbon with carbon dioxide. So more carbon with carbon dioxide to produce the carbon monoxide. So you just have to put this into writing. So you can say stage 1, describe how the reducing agent is produced. So by reacting the carbon with oxygen to produce carbon dioxide. Then the second one, the carbon dioxide from stage 1 will be reacted with more carbon to produce the carbon monoxide, which is what we want here. Then what is the purpose of each of the following? So hot air to react, so say to react with the coke or carbon to form carbon dioxide. Then the function, purpose of coke the purpose of coke to react with carbon dioxide to form carbon monoxide. So show the balance equation in which iron is extracted from the ore. Remember, we looked at 5 equations. So I say the third equation is the equation that summarizes the reaction, the extraction of iron. So that is the equation that you are supposed to give. The equation is, we said we have iron 3 oxide solid reacting with carbon monoxide, a gas. Then we have iron solid plus the carbon dioxide. Then to balance, we put a 2 here, 3 here, 3 here. So these are some of the questions that you may expect from the extraction of iron. So I just wanted to see how I can summarize the extraction of iron based on the question that we have here. So if you have some questions that you may still want me to look at under the extraction of iron, feel free to write in the comment section below. We'll look into that. So that's it for this video. Thanks for watching.